My name is Erin Wolf. I'm a chemistry teacher at East Greenwich High School in East Greenwich, Rhode Island. Today, we are going to explore a gas that hopefully all of you are very familiar with. That gas? Carbon dioxide. We're going to begin by taking a look at a video clip from NASA, and I want you to watch this video clip with a critical eye. It's going to show us how carbon dioxide moves in and out of our atmosphere. This video may make you think of a lot of questions, and I'd like you to keep those at the forefront of your mind as you're viewing the video. When the clip is over, you'll be asked to turn to a partner and to discuss any observations or questions you had while watching the video. I'll be back when the clip is done.
Hi, this is Bill Putman. I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth's atmosphere. The visualization compresses 1 year of data into a few minutes. Carbon dioxide is the most important greenhouse gas affected by human activity. About half of the carbon dioxide emitted from fossil fuel combustion remains in the atmosphere, while the other half is absorbed by natural land and ocean reservoirs. In the Northern Hemisphere, we see the highest concentrations are focused around major emission sources over North America, Europe, and Asia. Notice how the gas doesn't stay in one place. The dispersion of carbon dioxide is controlled by the large-scale weather patterns within the global circulation. During spring and summer in the Northern Hemisphere, plants absorb a substantial amount of carbon dioxide through photosynthesis, thus removing some of the gas from the atmosphere. We see this change in the model as the red and purple colors start to fade. Meanwhile, in the Southern Hemisphere, we see the release of another pollutant, carbon monoxide. This is a gas that's both harmful to the environment and to humans. During the summer months, plumes of carbon monoxide stream from fires in Africa, South America, and Australia, contributing to high concentrations in the atmosphere. Notice how these emissions are also transported by winds to other parts of the world. As summer transitions to fall and plant photosynthesis decreases, carbon dioxide begins to accumulate in the atmosphere. Although this change is expected, we're seeing higher concentrations of carbon dioxide accumulate in the atmosphere each year. This is contributing to the long-term trend of rising global temperatures. The Orbiting Carbon Observatory 2, or OCO2, will be the first NASA satellite mission to provide a global view of carbon dioxide. OCO2 observations and atmospheric models like GEOS 5 will work closely together to better understand both human emissions and natural fluxes of carbon dioxide. This will help guide climate models toward more reliable predictions of future conditions across the globe.
Welcome back. So I'm sure your group was able to come up with a number of questions. Some of the questions I thought of were, how is carbon dioxide introduced and removed into and out of Earth's atmospheric system? How can we know whether the patterns observed are just the natural cycles of matter on Earth, or whether these patterns of carbon dioxide concentrations are abnormal in some sense? What effect does increased carbon dioxide have on our weather or climate? So in our activities today, we're going to answer many of these questions. Our next activity, we are going to take a look at how carbon dioxide cycles into and out of Earth's atmosphere, and how these processes are part of the natural cycles of matter on Earth. The way carbon dioxide moves into and out of the atmosphere is one of the processes collectively known as the carbon cycle. With your class today, you will build a model showing how carbon dioxide moves through the cycle. The larger and more complex carbon cycle shows how carbon transitions through Earth's systems over time. This includes various chemical reactions as well as various phases of matter, such as liquid, atmospheric, and solid. We'll be focusing on two important components of the carbon cycle, carbon dioxide entering and exiting our atmosphere. In the next activity, your group will receive samples that illustrate different parts of how carbon dioxide enters into and out of our environment. You will decide, along with your group, which part of the process each sample represents. Once the samples are set, you'll verify the accuracy of your model as a large group. Then, once the beginnings of the model are ready, I'll check back in with you to see what we're working on next. So how does your model look so far? I hope you noticed from your exploration in the way that carbon dioxide enters into and out of the Earth's atmosphere, you were able to see that there are lots of different repositories and sources of both carbon and carbon dioxide throughout our environment. Everything from animals to soil, from the oceans to oil, are sources of carbon. We are all carbon contributors. We know that matter is neither created nor destroyed, but its form can change. So as an example, when I drive, I take carbon from the environment, which came out of the earth as oil. I put it into my car after it's been processed into fuel, and then I take that fuel and burn it in a combustion reaction, which releases CO2 into the atmosphere as I'm driving away. So in our next activity, we want to take a look at how carbon moves into and out of our system. We need to take a look at the processes that carbon dioxide undergoes as it moves into and out of our atmosphere so that we can start to evaluate the impact that this has on Earth's climate. So I'll see you after you complete your carbon cycle models and think about the changes that happen to move carbon through our environment. Congratulations on building your model of the carbon cycle. Make sure you focus and identify which processes show carbon dioxide exiting and entering our atmosphere, because that's where we're going to focus our learning going forward. The carbon cycle contains a complex number of processes. Carbon dioxide is in a myriad of places in our environment and can undergo many changes depending upon where it starts. When I took my ride this afternoon, I took the carbon stored in the gasoline in my automobile and combusted it. One of the products of that equation is carbon dioxide. Here's the equation for that reaction. Every time the engine burns 2 moles of gasoline, 16 moles of carbon dioxide are added to the atmosphere. If you think back to the NASA video clip we actually saw carbon dioxide cycling through our environment. It can be absorbed by our oceans, it can be absorbed by our plants for photosynthesis. Plants absorb carbon dioxide and can react 6 moles of CO2 with 6 moles of water molecules to make food, 1 mole of sugar that is used or stored, and 6 moles of oxygen that gets released to our atmosphere. So as we saw in the NASA video, we could see that as we get further into the summer, the CO2 that is cycling into and out of the atmosphere is a lower concentration due to the fact that so much of it is being absorbed by green plants for photosynthesis. Carbon dioxide cycling has been cyclical and has always been cyclical.
This graph shows the carbon dioxide concentration values at Mauna Loa, Hawaii over the past 5 years. The red graph has 12 points per year, indicating each of the measured monthly values. You can see from the red line, the carbon dioxide concentration values are constantly changing. The values increase in the winter months, then decrease in the summer, as was mentioned earlier in the NASA video, and this pattern repeats over time. The black graph is a smoothed running average in which the seasonal oscillations have been removed. What I want you to notice is the upward trend of this smoothed black graph. Its strongly positive, almost constant slope shows the steady continual rise in carbon dioxide concentrations. This line implies a greater amount of carbon dioxide gas is being released into the atmosphere, much of it resulting from combustion to produce electricity, provide transportation, and facilitate industrial purposes.
At this point, you may be asking the question, how does an increased concentration of carbon dioxide in our atmosphere affect the Earth's climate? You may have heard carbon dioxide referred to as a greenhouse gas. A greenhouse gas absorbs infrared radiation. Infrared radiation is originally emitted by the sun. It is then re-emitted from Earth's surface. and it is trapped as heat in the lower layers of Earth's atmosphere. This helps maintain temperatures that are conducive to life, but can have other effects. There are other greenhouse gases, such as nitrous oxide and methane, but in this experiment, what we're going to model are the effects of carbon dioxide concentration on atmospheric temperature. So let's head into my lab room to do some experimenting to evaluate those effects. So let's take a look at our model. So we're using this flask to illustrate an atmosphere that's closed off from the rest of the environment. This atmosphere is being shown over a large body of water, such as a lake or a pond. So the right bottle is our control. The left bottle is going to be our environment with increased carbon dioxide. I'll be adding an Alka-Seltzer tablet to our system in order to increase the concentration of carbon dioxide gas. Once I add my Alka-Seltzer tablet to the flask, I'll close my system and turn on my lamps. My heat lamps will be modeling the sun's rays, heating up my atmosphere. At this point, you're going to want to turn to a partner and make a prediction of what will happen to my model once the heat lamps are on. Your teacher may pause the video to facilitate this process. After 20 minutes of data collection, you will evaluate the temperature data collected by my probe and see what conclusions can be drawn. Let's begin the demonstration. Here's my data that I've collected while heating my models over the past 20 minutes. Your teacher will provide you this data and allow you time to analyze it. I'll check back in with you once you've created a graph and analyzed your data. What did you notice about your data? What patterns emerged when you graphed your data? I hope you noticed that the CO2-rich environment had a significantly higher rate of temperature increase than our control environment. It might not have seemed significantly warmer between the two flasks in the model that I shared in the demonstration, but climate scientists are in general agreement that an average increase of just 2 degrees Celsius across the planet could have significant effects on crop production and cause sea levels to increase, which would result in flooding. If you think back to the model of the carbon cycle that you created earlier, this increase in carbon dioxide concentration is only one process that could cause an impact to our climate. You have learned that carbon dioxide is created, used, and stored in many different ways on Earth and undergoes varied processes that impact our environment. I hope this Blossoms lesson inspires you to learn more about our climate and the factors that affect it. Today we focused only on carbon dioxide, but it is not the only greenhouse gas. You may be wondering how other greenhouse gases, such as methane or chlorofluorocarbons, have impacts on our atmosphere. This is such a vast and important topic. I know your curiosity must be piqued, and you can't stop your learning just based on this one demonstration. Thank you for learning along with me today. Thank you for inviting me into your classroom today. This lesson is a hands-on introduction to the chemistry of climate change. This lesson is designed using the 3 dimensions from the framework for K-12 science education to align with the next generation science standards. In this lesson, students will be engaged in several of the science and engineering practices, and their thinking guided by questions and prompts using the cross-cutting concepts. This lesson was designed to have students engage with the phenomenon of carbon dioxide entering and leaving our environment to explore the carbon cycle and the effects carbon dioxide gas has on the environment. This lesson can fit in a variety of contexts within a chemistry curriculum. It could introduce a unit on climate and climate change. It could also fit within a lesson on heat and energy transfer, or as a phenomenon for a lesson on stoichiometry, as the calculations could involve quantities of carbon dioxide gas. In this lesson, students will complete 4 activities. Activity 1, students will generate questions from a video phenomenon. Activity 2, students will begin to develop a model of how carbon dioxide moves through the carbon cycle. Activity 3, students will evaluate and refine the model of how carbon dioxide moves through the carbon cycle. And Activity 4, students will analyze and interpret data provided from an experiment illustrating the effects of carbon dioxide on atmospheric temperatures. Once you've shown the video clip for Activity 1, you should have students turn to a partner to construct questions. As the teacher, you should observe these conversations and facilitate student questioning using prompts such as, what patterns did you notice when you watched the video? From what areas did the carbon dioxide seem to be generated? What could be some of the causes of the patterns that you see? And why do the carbon dioxide values appear to change over time? It is recommended that you time your students to keep them on task. They should record the questions they generate in a notebook or a digital document, or maybe even on a whiteboard. While the students discuss, the teacher should be moving throughout the room, encouraging the students to think and prompting them with the ideas indicated. In Activity 2, the teacher should have the following pre-printed: a copy of the carbon cycle process signs, a copy of the cycle product signs, a copy of the student carbon cycle model for each student, and a copy of the teacher carbon cycle model answer key. The teacher should facilitate a space where the carbon in product signs can be spread out in a shape similar to the shape in the student model. Suggestions of spaces could be in a classroom, on a classroom floor after moving the desks out of the way, in a hallway space, or in a gym if available. The teacher should then obtain the following materials to be used as the carbon in products in order for students to generate the model. You would need a stoppered test tube, which would be labeled atmosphere, grass or a leaf, or you could use a picture, a hand mirror, a bag of soil, a test tube of water that's labeled seawater, seashells, coal, a test tube of motor oil, and limestone. To begin Activity 2, you should divide your students into 4 groups, and each group should receive 2 of these products listed above. One group will need to receive 3 products. The students will read the signs spread throughout the space, and they will make a decision for which product sign makes the most sense with the item that's in their hand. They will assign their product to that sign. If there are any students who feel that 2 products fit on the same sign, the class will ask those students clarifying questions to make a determination as to which sign is the best fit for each product. Once the teacher has verified those decisions, the teacher will instruct the students to annotate their individual copies of the model. As the students decide which cycle product sign best matches the product they hold in their hand, the teacher should be moving throughout the room and monitoring their discussions. Asking questions of a group that appears unsure about their classification, or potentially questioning the rationale of a group that was quick to classify and appears confident in their choice. Activity 3. Once the students have watched the next video clip, the groups of students will receive the carbon cycle process cards. These cards will be used to refine the model, linking the cycle products from the previous activity through a transformation process. Each group from before will receive 3 processes. The students will follow a similar procedure, evaluating their model and determining which process links 2 of the cycle products together. If there are any students who feel that 2 processes link the same products, the class will again ask clarifying questions to make a determination as to which process is the best fit. Once the teacher has verified all the decisions, the teacher will instruct the students to further annotate their models and color code those processes which involve production or use of carbon dioxide gas. In this activity, teacher questioning will become more important as the students are attempting to link the products with processes that convert one into another. Teachers should probe students to think of examples in their own experience, such as gardening, visits to the beach, composting plant matter, that might help them link 2 of their products together. Teachers should be ready to facilitate discussions if 2 or more groups feel that a particular process links their cycle products. The teacher should ask the group for evidence of their decision and then ask them to evaluate any other links that might relate to their particular choices. Activity 4. Prior to this activity, students will watch a brief video to observe the phenomena of a carbon dioxide-rich environment retaining more heat energy than an environment with less carbon dioxide. The teacher should provide the students copies of the data collected in this activity. Students will analyze this data by creating a graph of temperature versus time. Students can do this either digitally or on paper. Once they have graphed the data, the students have questions they should answer, either independently or within their aforementioned groups. While students are generating their graphs, the teacher can be prompting their analysis with questions such as, what patterns do you notice in your graphs? How do the patterns in the graphs compare to each other? Is there any data that does not fit within the pattern? Describe how the systems differ in the model and how the components affect the system. How is the data on the graph related to the flow of energy in the model? And how might this data set change when the scale of the model is not a small flask, but instead the actual Earth? Depending upon time and materials, this portion of the lesson could be done as an in-class demonstration or experiment. If so, you would have another set of data to compare to the data that I've collected, allowing for greater student analysis. I hope that after completing this lesson, students are familiar with the ways in which carbon moves through our environment and have some personal connection to the impact that an increased concentration of carbon dioxide can have on air temperature. My goal is to spark student interest and hopefully encourage your students to ask and investigate other questions about climate.